In this video, we're going to be covering derivations. And derivations are ways to create objects off of existing geometry, whether that be solid geometry, surface geometry, or even open or closed wires. Derivations can be found under the Derive palette, which is the fourth row down in the first column. Let's start with the most basic derivation, starting with this cube object. So if I click on the point cloud tool and then select my object, where any of these vertices come together, we are going to get a point. So I'm going to click on that, and you can see it gives us those points. And those exist in 3D space at each corner of the object. I'm going to undo that, and let's take a look at segments now. Now, if you hover over a segment, you'll see that it'll highlight. Now, if I hover over the object, I get no highlight. So this is where pre-pick and post-pick are going to come in handy. If I post-pick, which means I select the tool first and then select the different topology that I want to extract from this object, you'll see it can only highlight one at a time. So if I click on that, it gets rid of my entire object and just leaves that segment behind. And I'm going to undo that, and this time I'm going to pre-select my entire object, and now I'm going to derive segments, and because it's already selected and I click to execute that command, you'll see that I get each one of the bordering edges that goes around this cube. And again, that's all in 3D space. It leaves those exactly where they were in the cube. It just derives those down into individual segments. So just selecting each one at a time, I can get to those. So you can also think of this as an explode tool of sorts, where if I wanted to get the edges of a face or the edges of an object, and in another program you might use an explode command, in Form Z you would use the derive command to get at those. Let's take a look at the next one, which is to derive faces. So again, hovering over any face using the post-pick method highlights that face, and then I can click on it to derive just that face. If I click on a face on the side, it will derive that face as well. Now, what's going on? Why is it deleting the rest of my object? Well, this has to do with the operand settings. If we look under the Edit pull-down menu, there are three different options to ghost operands, delete operands, or keep operands. And you'll see by default, delete operands is turned on. Now, there's also three buttons in our main toolbar here at the top for ghost, delete, and keep operands. An operand is the object from which you are deriving from in this case. So if I click on the delete one and I derive a face, it will delete the original object. So this is where I want to introduce the idea of ghosted objects in Form Z. I'm going to click on the Ghost tool, and if I look under the Edit menu, you'll see that the Ghost Operands is selected here as well. So those are one and the same. If I click on the face now, you'll notice that it leaves a ghosted object. And this ghosted object is not selectable, it's kind of locked, it's kind of halfway hidden, but it gives us something to reference as our original object. And Form Z has a separate tool to get these objects back from the dead under the Attributes panel down here. You can see that we have two options. We can ghost objects and we can unghost objects. So if I wanted to get this object back, I can actually unghost it and bring it back from the dead. Now, the other nice thing about ghosted objects in Form Z is that you can actually snap to them. So if I were to click on a drawing tool and I were to start to draw, maybe I want to snap to this object as a reference. Now, by default, this is turned off, but if you right-click and go into your snap options down here, you can turn on snap to ghosted objects. So if I close that now, you'll see that I get the preview dot for my snaps on ghosted objects as well. Now, ghosted objects also live in objects and layers. So I'm going to click on the Add a Layer button and just enter into layer 6 here and make that layer active. And I'm just going to draw an object to show you how this works. So just drawing a rectangular kind of an object over here. If I now look under the Objects menu, I have a new object and I have a new layer. And I have Form Z set up right now to highlight which objects are selected and which layer they're on is selected. So if I deselect that, you'll see that those turn white. If I select my object, you'll see that both of those turn red. Again, that is found under the File, Project Settings. And if I look into Layers, I have highlight pick turned on, and I have objects, I have highlight pick turned on. So if you want that functionality, you'll want to set that up. So that's a quick and easy way to find out which object that is, because Form Z just numbers objects by default. Of course, you could always customize that if you wanted to, but the same goes for layers. So if you have lots of layers and lots of objects in your file, that can be a useful tool. Now, in the visibility column for each one of those, we can turn the visibility to ghosted or off. So there's 3 different states for visibility. There's visible, there's ghosted, and there's invisible, right? Same thing goes for layers. I'm going to go back to my original layer because you can't ghost an active layer, so I'm going to make that layer inactive, and I'm going to also ghost that there as well. So you can see we can ghost things various ways. Now, if I choose to ghost it in one of these locations, the object isn't gone, obviously. It's still here. This is just kind of an alternate display. When I'm talking about operands, where I actually am deriving an object from another one, that object is gone and I actually have to unghost it. So you can't unghost a layer, you can't unghost an object that is a live object. You can only unghost objects where derivatives come from, for example. So it's a little bit confusing maybe, but the more that you use it, the more that you'll appreciate this tool, because it does allow you to get objects back that you maybe thought were gone forever. So I actually like to leave the ghosted operands turned on instead of delete, even though it does make your file size larger because those objects still live in the project scene file database. It is very useful to be able to get those back sometimes. Now the other option is to keep your objects, right? So if I undo a few steps here back to my original cube and I keep, now I'm going to derive a face of this cube, and you'll notice when I derive that face, it left the original cube there. So if I move my original cube over, you'll see that it's still there, completely intact, with my new face that I derived from it. So this is different than unstitching, which we've covered in a previous video. If I unstitch this face, it will make a hollow cube, which is the remainder of the cube, and it will give me a face on the side here. Deriving a face puts that new face directly over the old face, but it does leave both objects intact. So that's what the keep operands does. I'm going to go back to the ghosted operands just so that we can get used to that a little bit more throughout the rest of this video. Some other options in the Derive palette include 2D walls, so I can click on a face and turn that into a 2-dimensional wall, and you'll see that we have justification in the tool options and wall width. Going to undo that. Let's go look at extrusions. So if I click on a face, it extrudes it. Now the extrusion derivative is only additive. This is not like using the reshape tool, which we've looked at in a previous video. So if I click on reshape and maybe I choose to keep edges and pull this face out a little bit, you'll see that this is still one single object when I select it with the pick tool. It just happened to leave those edges behind, which is going to look very similar to what I'm about to do here with derive extrusion. So I'm going to click to derive that out, and now I actually have 2 separate objects. This extrusion is completely derivative, and if we look at the tool options, you see that I have the option selected right now to derive this perpendicular to the source surface. So if I derive from this one, and then maybe I derive from this one, you'll see now I actually have 4 objects. I have this derived solid, I have this derived solid on the right, and then I have a newly derived solid in the corner here as well. So this is only additive. If I were to derive in the opposite direction with the extrusion tool, it doesn't take away from my original objects, they just happen to both overlap now. Next up is the point extrude option, and we can point extrude one face at a time. Or like we talked in a previous option, I can pre-select my object. Now, in this case, I actually need to pre-select all of the faces of the object, not at the object level, because point extrude works on a face-by-face basis. So I'm actually going to switch to wireframe view mode so that I grab all the faces, even the ones I can't see, by selecting these all with a crossing window. Now if I go to the point extrude button and click on it, you can see I can actually extrude all of those faces at the same time. And if I switch back to my shaded work mode, you can see that shaded, so it makes a little bit more sense about what's going on. And I can extrude all of those faces to points at the same time, which is very useful when you want to make really interesting geometry. So let's test that a little bit further. Let's go ahead and draw another kind of a shape over here. In this case, this is an icosahedron. And again, I'm going to select faces in wireframe mode, so that just makes it easy to grab all of the faces of this object at the same time. And then if I go to the point extrude button, It's set to perpendicular to surface. And this time I'm going to turn off dynamic, and I'm going to set the height to something a little bit lower, like 5 feet, and then just click. And you'll see that it adds a converged face to each one of the faces on the isosahedron. So a great way to make complex geometry very quickly. Now these are all separate objects because each face was derived independently. So you can see that I can click on each different point extruded object that came from those original faces, and it selects those as individual entities. Next up in the Derive palette, we have the 3D wall tool, and 3D wall will take any face and turn it into a 3D wall at whatever orientation it is. So if I click on there, because of the settings I already have set in the tool options, the justification is set to the left, the wall width is set to 2 feet, and the height, which was not set to dynamic, is set to 5 feet. Now, still in the object buffer mode, I can change those settings if I wanted something else. So for instance, I could have that frame go to the outside. I could change it to be thinner, like 1 foot, and I could change the height to be some different number, like 10 feet. And we can get all those numerically. Now, the cool thing about derivatives like these are I can select my object, I can go into the inspector and look at the parameters, and I still have all of those parameters to choose from. I can also show control, so I can now modify those graphically if I wanted to as well. And it maintains all of those parameters, which is absolutely fantastic. So if I select that object and I wanted to change the wall width, now in this case, I can still go to 2 feet thick. I could change it so that the offset is on the inside instead of the outside. And this is a great way to modify your parametric geometry even after you've derived it from that original source object to create new geometry. Now there's a couple of other options that I want to point out under the Edit pull-down menu, and there are 2 here. There's Place Derivatives on Active Layer, and there is Derivatives Use Current Material. So I haven't been using that because I'm putting everything on layer 1, but if I wanted to make a new layer active by creating a new layer, let's just call this Derivatives, and let's go ahead and make that layer active. And now if I were to use the 3D wall tool and maybe select a different material color and I click on this face, you can see it actually updates the derivative to be the new material, and it is placing it on the new layer. That can be really useful, especially in complex files where you want to see the results of your derivative. So let's say I wanted to derive a face from this cube and I want to keep my operands just to make this as confusing as possible. Well, with the Edit pull-down menu with these 2 options turned on, if I click on this face, you can see I get a new object on that new layer with that new color, and it left the old object behind because we had keep operands turned on. So that's a great visual way just to see when you're creating new operands where they end up. So let's take a look at derivatives with a little bit more complex of an object. I'm just going to focus on a couple here so that we can see what these look like. The first one I'm going to choose is 3D wall. Once again, I can 3D extrude a segment and just get a 3D object protruding right off of the orientation of that segment. I could also choose to 3D wall extrude a whole face at a time, or I can do something entirely different and I can choose a segment sequence, right? So if I choose this tool option from the pick tool, I can now hover over an entire row of these segments and select it. And now if I choose the 3D wall tool, again, it's set perpendicular to surface right now. And you can see that it will just create a ring all the way around that. And if I were to select multiple faces, for example, all at the same time, so if I hold down the Shift key and select every other face around this ring, for example, and then click on the 3D wall tool, and this time I'm going to turn dynamic on. And if I click, you can see I can extrude all of those as a 3D wall all at the same time. So very powerful and time saving. And again, these are all parametric. And I can change the settings in the parameters of all those objects once they're in the object buffer. Or I could go into the inspector, into the parameters tab, and update their parameters at any time after that. Another tool in the Derive palette is the Frame tool, and this will take any solid geometry and at every segment it will turn it into a parametric frame. So In a previous video, we covered the pipe tool. The pipe tool works with open wires or closed wires. If you have a solid object like this, you'll want to use the frame tool. And I'm going to go ahead and delete my original operand here so that I don't have my solid underneath it. I'm just going to click on the frame tool, click on the object, and it's going to turn that into a three-dimensional frame. Again, this is parametric. I can change this afterward to something smaller and make it a little bit thinner and elegant, and it will update. So let's take a look at another tool we have in the Derive tool palette, which is the project tool. And to visualize this effectively, I'm going to go ahead and turn on the ghost operand so that we can see the original object as a ghosted object with our new object. And looking at the tool options, you'll see we have two options. We can do a projection of the view or an orthographic projection. I'm going to choose orthographic. I'm just going to simply click on this 3D twisting spline that's floating in space here. And when I click on it, you'll see it projects it directly down onto the reference plane. And if I go to my top view up here, see that those match up exactly. So that's a really great way to flatten a curve or to project it down. I can then use something like a 3D wall derive tool, and I could derive that curve up vertically. And you can really start to get some interesting geometry from something that would have been impossible. For example, I cannot do a 3D wall extrusion of a three-dimensional spline through space. So I would use something like a project tool first to project that down, and then choose the 3D wall tool to get what I wanted. Then maybe I cut it up in a different way. Now, like I said, it projects that curve down onto a reference plane. So if I change the orientation of my reference plane, so now I'm looking at this from the front view here, and I use the project tool, it's going to project it onto the reference plane in that method as well. So this is very dependent on the orientation of your reference plane. So for example, if you wanted to create your own reference plane, which I have here in another layer, which is just a plane in space, I can now project onto that by using that to set an arbitrary reference plane. So I'm going to click and define my own reference plane. You can see that now my reference plane is attached to that face that I have drawn. And now if I use the project tool, it's going to project it onto that plane as well. So lots of flexibility and options with the way that projections work inside of FormZ. So let's look at a practical example of a potential workflow here. This is a two-dimensional surface that I drew in the front view. So if I click on front, we can see that this is kind of the rough shape of a house or a barn. And let's derive some different geometry off of this shape. So the first thing that I'm going to do is I'm going to select the four sides that I want to keep for another object. So I'm going to just grab all of these. I'm going to make sure that I'm on my keep operands because I don't want to get rid of my original source, and I'm going to derive segments from those. So clicking there, and now I'm going to move those segments in 3D space so that we can see that we actually have the original source geometry and our newly derived segments. Now each one of those derived segments is an independent object, so I'm going to go into my edit palette and I'm going to join these together. So clicking on that, you can see now it's a single object. And now what I can do is start to make a couple of really interesting moves with my geometry. Now I'm going to reorient my reference plane to vertical, and I'm going to use my 3D wall tool to get a three-dimensional roof-like structure. And remember, right now we have this turned on so that it's going to be placing it on the active layer, and it's going to give it whatever material is selected. So we can see very quickly we got a three-dimensional roof structure off of that. And again, this is parametric, so I could change the thickness of that. Let's go with 2 feet thick to make that a little bit thicker. So now let's turn this original source shape into glass and mullions. So the first thing I'm going to do is I'm going to paint this with a new material that I've made called glass. And I'm going to choose my paint tool in the attributes palette, click on that object to turn it into that. And now with my derive tool, I'm going to derive a three-dimensional mullion system all the way around. So I've created a layer called mullions. I've made that layer active. Remember, under the edit menu, we have derivatives, use current material, and it's going to place derivatives on an active layer. The last thing I'm going to do before I derive that mullion is I'm going to click on my new material that it's going to inherit when we do the derivative. And now I'm simply just going to click on that surface, and it creates the mullion surround that goes all the way around the outside. Once I've done that, I can take my original glass surface and maybe move it back to the middle of the mullion, just so that it's placed inside the glass there. Makes it look a little bit cleaner. And now what I'm going to do is I'm going to select my glass, I'm going to right click on it, and I'm going to isolate it. Now you'll see what we now know as ghosted objects surrounding this, which gives us some context, which is very handy. But I have my glass object isolated, and I'm going to use my mesh tool now to mesh this object into several different segments. So clicking on it, we can see now we can adjust these numbers to make them whatever we want. And if we wanted to divide this up into 6-foot increments or maybe 4-foot increments, doing this all in the x-axis, you'll notice that only x is checked. If I turn on y, I can get mesh edges going the other direction as well, but that's not what I want. I just want the vertical ones. And I'm going to go ahead and then deselect that. Now I'm going to grab all of those segments that I created using the pick tool and pre-picking each one of those segments. So holding down the shift key, I can grab all of those segments. And now I can derive 3D walls based off of all those. Once again, I'm going to reorient my reference plane so that FormZ knows exactly which direction I want these to go. I'm going to click on the 3D wall tool, and using the same settings as the original mullions, I'm now going to just click to derive all of those at the same time. Now I can right click and I can reveal my objects. And I have all of my mullions here. Let's go ahead and just grab those new mullions that we created and change their properties in the inspector. Let's go to parameters and let's say I want these to be half as thick, so 3 inches thick and maybe only 6 inches deep. And maybe then I want to move those. So I'm going to orbit underneath, take a look at those in their location and move them back a tiny bit so that they're not protruding quite as much. And there we have it. From a very simple surface as a starting point, I was able to get all of these parts using FormZ's powerful derivation tools. Thanks for watching, and if you'd like to get notified when new videos are released on this channel, click the subscribe button below and click the notification bell icon to get a notification when new videos are released. See you in the next one.